Hello, we will present the topic of Pythagorean theorem. There are total 3 people in our group. I'm KAKI. I'm in charge of the outline and background with this topic. Qicheng will focus on different methods to figure out the hypotenuse. JINGYI will in charge of the Pythagorean theorem in real life and conclusions. The Pythagorean theorem was one of the earliest theorems known to Asian civilizations. This theorem is named for the Greek mathematician and philosopher by Pythagoras. Maybe the Pythagoras theorem is the first theorem we learned in math. It seems like really easy to using simple formulas to evaluate triangle problem, but there were about 150 mathematicians try to solve and prove by different ways. In mathematics, the Pythagorean theorem is a fundamental relation in Euclidean geometry, almost the 3 sides of this triangle. In the past year, it has some famous people to evidence the Pythagorean theorem. For example, Albert Einstein. He was giving a proof of dissections in which the piece need not be moved and shapes that includes the hypotenuse on this triangle. However, the Pythagorean theorem can also demonstrate on these 4 categories. The first one is algebraic proof, the second one is geometry proof, and the third one is those by the vector operation, and the last one is the dynamic of proof. And now, Qicheng will present the different methods to figure out the hypotenuse.
Thank you, Kaki. Kaki has introduced to the history of Pythagorean theorem and studied by some mathematicians. Now I'm going to show you 2 different ways to prove Pythagorean theorem. The first method is something we haven't learned in Mathematics 1 to 3, but it's one of the easiest way to prove. And the second method that I'm going to apply what I learned in class is distance formula. That means I'm going to evaluate the right triangle problems by using distance formula. Okay, let's move to the part B, the first method. Here we got 2 big squares, and these 2 big squares have the same side as A plus B. It's not hard to see. There are 3 smaller squares, 1, 2, 3, and 8, same triangles in these 2 big squares. And based on these 2 big squares, we got an equation. On the left side, it means the area of smaller square 1 plus area of square 2 plus 4 times half AB. 4 times half AB means the area of these 4 triangles. And the right side is C square. It means the area of square 3 plus 4 times half AB. And we simplify it. We got the A square plus B square equal to the C square. And simplify more, we got the C equal to the square root of A square plus B square. That's what we learned about Pythagorean theorem. Okay, let's go to the second method. Suppose we haven't learned the Pythagorean theorem, but we still have to find out the hypotenuse in a right triangle. What should we do? We can use the distance formula that we have learned in the class. First of all, we need to set up an axis and we put a triangle on the axis. The 2 smaller sides on the longer side are A, B, and C. And set A and B are parallel to the x-axis and y-axis. So it's a right triangle. And that's called the 2 points link the distance C are alpha and beta. And the coordinate of alpha is x1, y2, and the beta is x2, y1. Okay, we got everything we need to find out the distance C. Let's put them into the equation, into the formula. We got an equation like this. And the way to simplify. x1 minus x2 is minus A, and the y2 minus y1 is equal to the side B. And finally, we got the distance C, and it's also the hypotenuse of this right triangle. As you see, it's same as the equation we got in the first method, so it means I did this with another way. Thank you for watching my part, and next will be River. River will talk something about how the mathematical knowledge related to the real life and how to use it. Thank you.
Thanks to Kevin's clear explanation, it turned out there's a variety of the proofs of Pythagorean theorem. We take two methods in order to link distance between 2 points and 2 squares, which will help us to expand the scope of Pythagorean theorem. And the use of it is far more than this. The Pythagorean theorem is based on the real life and defining reality. Combining number and figures, we can figure out many problems are closely related to real life. Now we will discuss the analysis of Pythagorean theorem in real life of concrete application. Some picture here showed how Pythagorean theorem used in architecture and our daily life as well. Of particular note that all Pythagorean theorem only happens in right angle triangle formed by the horizon, which is this line, straight line on the base. Taking a building a roof as an example, as we can see, the roof is a big right angle triangle, which made by two small right angle triangles. By measuring and calculating, we can figure out the length of the hypotenuse, which is the length of the roof's both sides. And then, how much material going to use is simplified. In conclusion, Pythagorean theorem is a lot more important than it initially looks. In this group assignment, we used 2-point distance formula that we learned from MATH123 to prove the Pythagorean theorem. We impressively learned that math is interchangeable in some way from this assignment. That's all for our group assignment. Thank you for watching.